Yeah, so that's kind of our goal today, because I want to give you time where you can actually kind of work on this. So let's see. Ooh, I got most here. Let's see. Let's see. So Alexis coming?
Yeah.
Let me get rid of that. I don't need that on the board anymore.
How do you know?
Where are we at? So, where's my cursor at? Nowhere to be found.
Oh, I just saw it.
Yeah. I think I'm too zoomed in. Oh, there it is. That's the problem. It's too zoomed in. I can see.
Yeah.
Okay. So this is Maddie. Boom, boom. All right.
Anyhow, when do you move?
Well, we actually,
It's not for a while.
Okay. All right. So here's the idea. Obviously, you have a study guide in front of you that will help you out. Now, here's what I want to go through today. I'm going to put up here on the marker board kind of a PowerPoint that kind of goes through the idea of what we're doing here. It's going to have some different problems. We're going to do a couple of these. And I thought we probably should go through each type today. That way you get a sense for how to do problems. So like when you look at your problem number 1, it asks for factors. We started that last Friday. So if you were here Friday, we did talk about factors. We did talk about the different classifications of numbers. And I think we did a couple maybe adding and subtracting problems, maybe 1 or 2 of those. That's where I left with today. I want to start with those. You can go. Then what I want to talk about today is multiplying, and then go into the comparing numbers like fractions and whole numbers, and then eventually get to the fraction stuff. The fraction stuff should be probably the most familiar to us because that was the latest sections we've been doing. But let's start the review here. All right, so I'm going to start off right at the bat. These problems are a lot like number 4 through 7. So look at your numbers 4 through 7. These are a lot like it. Now, here's the idea. What you're doing on those problems is you're trying to classify each set as rational, irrational, natural, whole, and integer. Those are in no particular order. On your paper, on the test, I should say, I will have those sets written down in order so you know which one's which. But let's kind of walk through the different sets. All right, so let's go through my 4, and then maybe I'll do 2 of yours on that little the handout here. Okay, so let's start with -9. What set of numbers, or sets, plural, could these fit into? Integers. Okay. Yep. So it could be an integer. That's probably the number 1 because it's a negative number. It's not a decimal, but it is a negative. So yeah, you're absolutely right. This would be an integer. And what was the other one? Rational. Rational can be anything that you can write as a fraction. I can write the number -9 as a fraction. I can put it over 1. So those are the only 2 categories it fits into. It's not a whole number. It's not a natural because it's negative. Those wouldn't apply. And it's not irrational. It doesn't have a little dot on it. So I think you can figure out later, is there an irrational number up here?
Yep.
Yeah, this one. You just write irrational, and it would automatically not be any other type. It's not repeating. It's not, doing the same pattern over and over and over. Those look like random numbers to me. It's automatically irrational. I don't have to think about it. It doesn't fit any other category. Those are separate categories. What about 12.4? It's rational. Now, here's why. You can make a decimal a fraction. Now, this one doesn't have a little dot, so it is just normally rational. It's not going to be a whole number. It's not going to be a natural because it has decimals. It's not an integer because, again, it has a decimal, so it just has to be rational. Okay, last one, 17. Yeah, it's pretty much all of them. It's natural, whole, integers, and rational. It's pretty much all of them. Okay, but the first set everyone always thinks of is whole, right? Because whole is pretty much every number, 0 to whatever. But it's literally every single category. Because if you pick the first 2 categories, everything falls after it. Literally. Like if you know it's a natural number, it's a whole, integer, rational automatically. Because all the other sets fall into place. So just hearing like just whole, it was automatically the other ones after it. Except for irrational. That's like a separate category. Questions on those? Now, let's look at your paper. If you're looking at numbers 4 through 7, I picked problems almost identical to mine up here. So number 4 there, it has an 8. Well, 8 is just a nice natural number. So that means it would be every category as well. So if you want to write that in there, so if you're looking at number 4, it would be a natural, it'd be a whole, it'd be an integer, it'd be a rational number. Because it's just a plain number, right? It's no negatives, there's no decimals. So it can literally fit every category. Okay, now if you go eventually down, you'll see one with a dot, dot, dot on it. That's what, number 6? That would be automatically irrational. The dot, 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 the number never ends. It doesn't look like it's repeating on yours. So those look like random numbers given, so it's irrational. Does that make sense what you're doing? Now remember, rational and irrational are different. Irrational never ends. Rational can be anything as a decimal or a fraction. So if you have a fraction, it's automatically rational. Automatically, it wouldn't fit the other categories. Okay, questions. Okay, that was the 4 through 7, correct? Hopefully you feel a little bit better about those. I think we started those last week. I think we did them on Friday. I think I did like 1 or 2 examples of it. But I thought we better talk about it. It's usually one of the first things people always ask. They don't know the words. But again, on test day, you will have that word bank like that. I'll make sure the word bank's on there for you. All right, let's move on. Where's the paper? There it is. Okay, next category. Okay, factors. Okay, so factors, so if you're looking, these are problems number 1 and 2, also number 3. Factors are numbers that obviously multiply to give you the one that's above. Now, I have 2 sets of numbers here. They're kind of closely related to the 2 that I picked for you. I picked numbers that were close, right? You had 24, I had 20, you guys had 48, I had 50. But the idea is that what you're supposed to do is try to break them up and to figure out numbers that multiply together to give you these. And you're giving me every number that's possible. Now, this is where a multiplication table can come in handy. So if you have one, you can take it out. If not, just kind of watch and we'll kind of go through it. I'll give you a multiplication table at the end of class here if you need one, once you get a little bit of time to work.
Do we get one for the test?
Yes, you'll have one for the test. So for number 20, you better make sure that you start with 1 and 20. So if you're doing your number 24, right, you better put 1 and 24. Because you know 1 goes into everything. It's 1 in the number itself. So 1 and 24 for you guys, for your problem with number 1. Okay, now the next one. I know 2 goes into it. It's 2 and 10. Right, those multiply to give me 20. 3 doesn't go into it. 4 does, 4 and 5. And since these numbers are basically the same number, they're so close together, I can stop. There's not going to be a number in between them. So there's your sets. Those are all the factors of the number 20. Again, if you had a multiplication table, just look for 20s and tell me the numbers that multiply together to give you those. For 50, same exact idea. What's the first set I should always use?
1 and 5.
1 and 50? For sure. Like 1 and 50. Because 1 goes in everything. So if you're doing number 48, you better start with 1 and 48. For me, I know 2 goes into it. Same with your 48, 2 goes into it. You just cut it in half. Well, half of 50 is 25. Pretty easy. Then I'll try 3. 3 doesn't go into 50. Because how I know that, these 2 don't add up to be a number that 3 would go into. 4 doesn't go into it. 5 does.
5 and 10.
5 and 10. 6 doesn't go into it because 3 didn't. 7, 8, 9, and we already had 10. So there you go. There's all your numbers. Now for you, I'm going to do the number 48 for you. So book the number 48. What do you got? All right, so that's number 2, right? I'm going to do that one for you. So here we go. Here's number 48. Okay, I already told you 1 and 48 goes into it. Okay, I already knew that. Like that's an automatic. You should automatically get at least a point there. 2 goes into it. So 2, if I cut 48 in half, just cut each number in half. That's a 2 and a 4. That's cutting 4 and 8 in half. Then I know a 3 goes into 48. It's 3 and 16. Go into it. Again, how I would know that, just take 3 times 16, you'd eventually get 48. I believe it's on the multiplication chart if you had a bigger one. 4 and 12 go into it. And then 6 and 8. And those numbers are so close together, I can pretty much stop there. All right, so there is your number 2. So you're trying to go to all the different numbers that multiply together that give you that. Now, probably on this set, probably the hardest one would be the 3 and 16. Because if you had a multiplication chart, the one that I provide you, it doesn't go up to 16. So you'd have all these other ones, but you wouldn't have the 3 and 16. So that would be one you'd have to think about. Is there a number between maybe 2 and 4 that would work? try to figure out some different numbers. All right, questions at all about number 2? So Dark, if you didn't get number 2 yet, there it is, so I'd write that down. Okay, questions on that though? I'm gonna leave that on the board, so if you can write that down. Okay, again, now, if they're asking for greatest common factor, so that is what, your problem number 6? Or 3, sorry, number 3. No matter what numbers, let's say this was your problem number 3, and it said, hey, find the greatest common factor. I would look at both sets and figure out what is the biggest number that they both have in common.
10.
For me, yeah, it's definitely a 10. So I just look at both lists and figure out the number that they both share, the biggest number they both share. Well, in my case, they have a 10. They have a 5, they have a 2, they have a 1, but I noticed the 10 was the biggest number they shared, so I'd circle that number. So on your number 3, you'd have to like break both numbers down and figure out a number that goes into it. Now, if you can't think of that, maybe you don't have the entire list for both numbers. Just pick a number that you know works, right? That when you look at both lists that you have currently, there's at least one number they probably match. At least circle that one. So you're at least giving yourself a chance to at least get it. Because some people, they go through those problems and they're like, well, I don't really know how to do it. I'm just going to leave it blank. When you could at least have 1 or 2 points because you could try to break it down as far as you could. Okay, questions on your first half there. The first top half, I should say. Okay, next set. Adding and subtracting numbers. I think that's my next slide here. Okay, adding and subtracting numbers. So these are problems like number 8 through what? 8 through 13? So around that ballpark? Okay, so here's the idea. What you're doing on 8 through 13 is trying to figure out, are you adding numbers together or are you subtracting them? Okay, that's the tricky part. So, yeah, it's that evaluate one, right? We're trying to find the exact number. So on these problems, I'm just gonna give you a hint. Like, this is the way that I look at your problems. I'll do a couple of yours so you can get a chance for this. Okay, when I look at these problems, obviously I don't need to cancel any negative signs here. This one I would, so I'm gonna cancel the negative sign there. So I have a double negative, so I'll cancel that out. Everything else is pretty much normal. Here's how I know if I'm gonna add the numbers together or subtract them. Are these numbers the same type of number?
Yes.
Yes, they're both negatives, right? You would add them together. So in this set, you add. Okay, I'm gonna add those 2 numbers together. On the next one, are these the same type of number? Negative 16 and a positive 84. No, they're not, right? One's a negative, one's a positive number, like positive 84, negative 16. I'm gonna have to subtract these numbers. I can look at it in the first second and know if I'm adding or subtracting. Because if they're the same type, you add them. Like on this one right here, they're the same type of number. They're both negatives. So I'm gonna add these together. So if they're the same, you add. If they're different, like in this case, these are different now, because that's a positive 17 now, and that's a negative 9, I'm gonna have to subtract these numbers. Okay, does that make sense how I know right away what you have? Okay, so let me give you, give me number 8 that you have. What's your number 8?
Negative 19.
Negative 19 plus 30, okay. So the first thing I look at, are they the same type of number? No, we have to subtract. Automatically, I'm gonna subtract these numbers. I don't care the order you write it, I usually always put the bigger number on the top. That way it guarantees that you're gonna get the correct answer. And I'm gonna subtract 19. Okay, bigger number on the top. It will guarantee your correct answer when you put the bigger number on the top. Because you're going the right direction on the number line. That's basically what it comes down to.
Oh.
Because if you switch them around, you could accidentally borrow incorrectly. So putting the bigger number on the top guarantees it. So on this one, 30 minus 19. Well, I'm gonna have to borrow, because I always start in the back number. I can't subtract 0 minus 9, so I'm gonna borrow, make that a 2. This is a 10. 10 minus 9 is 1. 2 minus 1 is 1. There's your answer, it's 11. Now, the last thing I have to think about is my answer positive or negative. Which number is bigger? Positive, so it's positive. This is how you think of it. Bigger number tells you your sign. Every single time, no matter how you do it. Okay, give me another one. So we did number 8. Let's do either 9, 10, 11, 12, or 13. 13. Give me 13. What do we got?
Negative 44.
Negative 24 and?
44.
Minus 44?
No,
Oh.
44 and then 16.
16, thanks, sorry. Minus 16, correct? Are they both negative? Okay, so in this particular problem, since they're both negative, I'm gonna add these two together. I can look at that the first second, they're the same type of number. So I'm gonna have to add these two together. Again, put the bigger number on the top and add them together, okay? So bigger numbers on the top. When we add straight down, so this makes 10, carry the 1 over. We add straight down, we get 6. The last thing, I look at which one's the bigger number. Well, the bigger number is a 44, and that happens to be negative, so it's negative. That's just how I think of it. The bigger number always tells you what the sign's gonna be in the very end on these problems. Even if you add or subtract. Okay, does that make sense?
Nope.
Okay, now, the next ones you guys have is multiplying. So that's your, what, the bottom two questions?
14, 15.
Yeah, so let's go to one of those. So here we go. Now, I don't really mind the method you use, because some people like to use the lattice method, like the scaffolding, all those lines and boxes. Some people like the column method. I'll do one of each here, so you get a chance to see how to do it. Then maybe I'll pick one of your problems, because obviously I think you have numbers that are very, very similar to mine. One's a 2-digit number, one's not. Okay. All right, so I'm gonna do it by each method. So the 9 and 12. Here's how it works for multiplying. If there's two negatives, the negative signs cancel out when you multiply. So this answer is positive. If there's one negative, it's automatically negative. You don't have to worry about which number is bigger. That's just how multiplication works. Now I'm gonna do the 12 and 9. So if I'm gonna do by column method, just stack them. Don't really care how you do it. And then you just multiply this bottom number to the top. So that makes 9 times 2 is 18. You always carry the next number over. 9 times 1, and then you add the top number. So 9 times 1 is 9, you add the 1, you get 10. And there's no other numbers to carry, so your answer is 108, for mine anyway. Now, if you didn't like that method, you could always do the little lattice method, where you make boxes, where this is 2 and a 3, for a 23, and this is an 11. And you put the little diagonals in each box, and what you do is you just multiply each number and you write a 2-digit number every time you do it. So, here's how it works. What is 3 times 1? 3. So it's 0, 3. That's the number 3, right? 2 and 1? 2. 2. 0, 2. 3 and 1? 3. 2 and 1 is 2. Okay, so there we go. Again, I just wrote down each 2-digit number as my answer. Then what you do is you just add up the diagonals. So in my case, my answer is a 3. This adds up to be 5. This adds up to be 2, and this is a 0. So it's 2, 5, 3. And my answers are both positive, so the answer is positive. Some people like that, some people really don't. Again, why I find this is probably one of the easiest methods for most people. If you have a multiplication chart in your head, or sorry, on paper, like you have a multiplication chart in front of you, you can do all these problems because all you have to do is multiply two numbers, and it's guaranteed those numbers are on your multiplication chart because they're single-digit numbers every time you multiply. So it will be on your multiplication chart, and you can fill those in. Okay, questions on the different methods? Okay, now, obviously you have number 14 and 15. I'll do one of them for you. Which one would you like? Which one? 15? Okay, let's do 15. That's what I heard. All right. Okay, somebody give me those numbers. What do we got?
Negative 17,
Times?
negative 28.
Negative 28. Okay, so we are doing bigger numbers. So I'm going to choose on this one to do it with the little lattice method, the little scaffolding. So, got my scaffolding, two numbers, 17 and 28. I'm going to put my little diagonals in each. Okay, and now we're going to write down each 2-digit number. So 2 times 7, 14. So that's a 4, 1 4. Next, 1 times 2 is 2. 7 times 8, 56. And 1 times 8 is 8. Okay, so here's where we're at. Now what we do is we add a diagonal. So when we add, this back number is automatically 6. This is going to add to make, let's see, 9 plus 8, what is that, 17, carry the 1. 1 plus 1 plus 2 is 4, and we have a 0, so this ends up being 476. And again, how I did that, you add up the diagonals as you go, and it will be positive, the two negative signs cancel
What
out.
if you have a negative and a positive?
So, it doesn't matter which number is negative, the answer will be the same number, it'll just be negative in this case. Okay. So yeah, so on multiplying, you don't think about which number is bigger, just one negative sign is negative. Adding and subtracting, that's where you have to like figure out, you have to either add or subtract and figure out what the last number is in the very end. Okay, questions on the first. That's the first page, right? Hopefully you kind of went through, you tried out a couple if you need to. Okay, let's flip it over. Let's do the second page now. All right, so let's do the second page here. Okay, so second page at the very top, you're comparing a bunch of numbers. So let me give you an idea here. Okay, let me get rid of all this. All right, so we're comparing numbers. They have that little blank in between, and they want you to figure out which number is either larger or maybe they're equal to each other. So I'm gonna do a couple of these, then what I'll do is I'll go to your paper and I'll help you out with one of yours. Because I think probably the hard ones are the fractions. That's usually the ones that get people. Okay, so on these, how I think of this, which number is larger? You think about where they fall on a number line, right? On a normal number line, 1, 2, negative 1, negative 2, negative 3. As you go this direction on a number line, the numbers are bigger. As you go to the right, so if you can think about where your number lands, the numbers on the right side of the number line are technically larger numbers. So between negative 4 and negative 19, which one's the larger number?
Negative 4.
Negative 4, right? Because negative 4 would be right here. Negative 19 would be way down the road this way, right? If I can draw my number line. So the idea is that negative 4 is technically a larger number. So we put the little alligator mouth facing the larger number, right? The bigger gap here faces the bigger number. The smaller like point faces the smaller number. Okay, now when we do absolute values, it changes these numbers to positive every time. It always changes positive. Now, which number is bigger, 26 or 15?
26.
26. That's how it works. Okay, on this, when we take the absolute value of negative 10, we get positive 10. Positive 10 versus negative 10. Positive 10 is bigger, right? Now, for fractions, because I know you have what, a couple of fractions, that's 20 and 21. You have a couple of fractions there. To compare these, what I would do is I would do this. I know this seems a little goofy. I would break up the bottom numbers, if you can. Okay. So, 11, I can't break it up, it's just 11 and 1, but 8 could be, what, 2, 2, and 2? That's the numbers when I break up 8, 2, and 4, and then 2, 2, and 2. And what you do is you make the bottom numbers the same. So what I do is I choose a number where I'm using all the bottom numbers together. Now, some people don't like to do that. They don't like to break it up. That's fine. You don't need to break up the 8. You don't need to break the 11. But what you do is you multiply the two bottoms together. That's what I'm basically doing here, 8 times 11. And when you do that, you just have to make sure you change the top, and this will give it away. So what I did here is I added an 11 to the bottom over here, so I'm going to put 11 on the top, making it a 77. That's 11 times 7. On the other side, I added a bunch of 2's to the bottom, that's 8. So I'm going to multiply an 8 to the top up here, that's 2, 2, and 2. That makes it 64. Which number is bigger, 77 or 64?
77.
77 is a bigger number. You make the bottom numbers the same and the top will adjust. So, let's do one of yours, because when you have 20 or 21, I don't really care which number you have. Somebody give me 20 or 21.
21.
21? Okay, give me 21.
8 over 11.
Say it again.
4.
8 over 12.
8 over 12 and
7 over 15.
7 over 15.
10.
10.
Oh, 7 over 10, I'm sorry. All right.
No,
10
over 15.
Oh, shoot. How did I hear 7?
Because it is 7.
Why is that bad hearing? Okay. All right, do I got it right? All right. So, here's the idea. I want to make them the same number. Now, obviously, these numbers are kind of larger. I don't want to just multiply 12 and 15 together. That would take forever. I don't want to do it. So I'm going to choose to break up the bottom. So the bottom 12 is 3 times 4, or 2 times 6. I'm not sure how to do it. I'm going to break up the 4 even further. It's going to be 2 times 2. Okay, on the other side, 15 is 3 times 5. I'm going to leave the top numbers alone. Now, what I want to make sure of is I make sure that I put all the numbers on the bottom so that the fractions are equal to each other. So, what I mean by that is I've noticed on the bottom there's 3's, there's 2 2's, so each of them need 2 2's, and that one has a 5, so each of them need a 5. So I want to make sure that each fraction has the same numbers on the bottom. So I'm comparing the bottoms to see what we have here. Now, on the top, how I adjust, since I added a 5 to this, I'm going to put a 5 on the top, making that 40. On this one, I added a couple 2's to the bottom, so I'm going to multiply a couple 2's to the top, making that 40. So, which number is bigger? 40 or 40?
40.
They're equal, put an equal sign between. They're the same fraction. Because again, how I'm doing that is I'm making the bottom numbers the same by comparing what's on the bottom. And when I make the bottoms the same digits, I adjust the top. So like on this fraction, I had to add a 5 to the top to make sure there's a 5 on the bottom. Over here, I had to add a couple 2's to the top. And this is the numbers I'm comparing, because the bottom should be the same number. I don't even need to multiply the bottom out. So they happen to be the same exact fractions on your number, what is that, 21? There you go. All right, questions? Probably the hardest stuff is comparing fractions. Okay, now the rest of the stuff that you have, it's like mixed numbers to improper. So let's go through a couple examples of those. I don't know if I have
His
some.
girlfriend.
Bless you,
His
Coach.
girlfriend.
Okay, it doesn't look like I have any mixed numbers, so we're gonna go through a couple of your examples on your practice guide here. That way you get a chance to see some of these. All right, so we're on the last few problems here. Somebody give me either 22 or 23. I don't really care which one.
32,
Okay, say it again.
32,
32
or 6.
over 6. Okay. Now, what number is this?
23.
23. Okay. So here's the idea. Okay. What they want you to do here is change this improper fraction to a mixed number. So what I mean by that is you got to figure out, how many full pies do you have, right? So this is a full pie, 6 out of 6 pieces. You have 32 pieces. They put too many pieces on a pie pan. So what I'm going to do is I'm going to break these up into multiple pans, like this. Now here's the hard part. I don't know how many I need. So you have to count the top and kind of add these up until you make a total of 32. Well, right now, currently what I have is I have 6, 12, 18, 24. I have 30 pieces of pie, so I need an extra 2 left over. Does that make sense? To make 32 on the top. Again, I'm adding the tops together to figure out how many total pieces of pie that I have. So far, and again, I was just making those up randomly to make sure that I can get up to 32. I didn't know how many I would need. So right now I've got up to 32 now because of all these 6's and a 2 at the very end. So how many full pies do I have here? 5 full pies, and that extra, the 6th pie that's extra, has 2 out of 6 pieces on it. That's how I change to improper fractions, or change it to a mixed number. I use the bottom number to figure out how many full pans I have to make a total of 32 of them. Okay, does that make sense? Now let's go to the next problems you have. This is problems number 24, 25. I'll just pick one at random. I'm going to pick number 25. What is that? 7 3/5. 7 3/5. Okay. Your goal on this one is to make it improper. There's a couple different ways you could do it. You could draw pictures, or what I'm going to do is I'm going to do the shortcut. 7 times the bottom, 7 times 5, and then you add the top. Okay? So what this is going to do, this makes 35, and I add 3 to it, making 38. And then you always put it over whatever the bottom number is. So that's the shortcut. Now, if you don't like the shortcut where you take 7 times 5 and add the top, here's what you can do. 7 full pans of 5 brownies. Right? 7 full pans of 5 out of 5. Now, why I'm picking 5 out of 5? Because that's what the bottom number is. That's how I know it. So I have 5 full pans. Sorry, 7 full pans. And the extra pan left over was 3 out of 5. 1, 2, 3, 4, 5, 6, 7. There we go. 1, 2, 3, 4, 5, 6, 7. All right. So you can do it this way, and then just count up total on the top. What you have here. Well, that's 38, if you count the tops, 38 over 5. That's another way you can do it. Okay, the last couple problems where you're multiplying and dividing fractions. Multiplying fractions, you would simplify it, and then you can multiply straight across. The problem is when you have mixed numbers. I want your number 27. This is my last problem of the day. All right, so give me number 27 here. What do we got? 6 and 4/5, and what are we multiplying it on?
15 over 8.
15 over 8?
18.
18
15
over
over 18. No, 15 over 18.
Thank you.
Come on.
I can't hear you. You gotta realize I'm really deaf. I'm serious, like I'm deaf. All right, so, okay, so first step, I have to change these to improper because this is a mixed number. So I'm gonna do the shortcuts. 6 times the 5 at the top, that's 30 plus 4 is 34 over 5. 15 and 18. Okay, so here's where we're at. This is number 27, by the way. All right, so that's the first step. Change it to improper. Now, it is a multiplication problem. I don't need to flip any fraction over. If it was a division problem, all I do is flip the second fraction over. Now, at this point, what I'm going to do is I'm going to break these up. So I'm going to think about numbers that multiply to give me these. 34 is 2 times, it's 2 times, what is that? Is that 3 times? Is that 3 times 17? No, that would be, so is it here, what is 34 times 1, that's 2, 1, 14, it is 17, okay. All right, so 17 and 2, that multiplies to be 34. 5 is just 5. 15, what are numbers that multiply to give me 15?
3 and 5.
3 and 5, okay, 3 and 5. I'll just put little dots. And 18, what, 2 times 9? I can break up 9 even further to be 3 times 3. Okay, so I'm at this point. Now, what we're going to do is we're going to look up and down. Is there anything I can cancel? Well, I have a pair of 3s, so I can cancel those out. Up and down over here, nothing. Now what I can do is I can go diagonally. Well, I have a pair of 2s. I have a pair of 5s. And now my last step is just go straight across. So your final answer on this problem, if I go straight across, there's a 17 left on the top, and there is a 3 left on the bottom, and that is technically the answer I'm looking for. Questions on that? Now the hardest part about that problem is probably 34. It's just a number you're not used to. I can pretty much guarantee you the numbers I'm going to give you tomorrow will be significantly easier than the ones I'm giving you right now. I just wanted to give you a chance to look these problems over. Okay, questions with any of the multiplication or division problems? Now, again, multiplication, division, if one of these is negative, my answer is negative. If 2 of them are negative, they cancel out and it makes positive. Okay, here's what I want you to do. Take some time today, look this over, study it. This is just a study guide. It's not a worksheet or anything like that. I want you to get a chance where you can try out some problems if you need to. I will not need this back. I will not. This is for you. I want to do at least enough of these problems you know how to do them. I'll post a video online right after school. All the other videos are online. I made sure of it last night that they're all there. They're all working correctly because we're on the second section now, the second half. So I want to make sure all of them are there in case you need to see them. Tomorrow, we're looking at a test. So keep that in mind. Test is tomorrow. I've been kind of warning you of that. It seems like we're somewhat prepared for it. We'll kind of see, we'll play it by ear. I might try a couple problems right in the beginning of class tomorrow. Let's kind of see where we're sitting. But test, we're looking at probably tomorrow. So keep that in mind. If you have any questions, come in after school today, come in before school tomorrow. Remember, you get a multiplication chart. That's pretty much all you get. But this practice guide is yours. You can kind of work on some problems if you need to. Your test is going to look like this. I'm not joking. All I do is change numbers. That's all I do.